The second lecture of probability theory set the background for the modern theory of probability. We first introduced the concept of random experiment, capital Epsilon, the sample space, capital S, and the definition of events. We then gave the main definitions and property of the events in the sample space, capital S. We noted that the modern theory of probability defines events in the language of set theory. We discuss what we mean by a certain event, by the impossible event, and by the operation of set complement, union, and intersection of events. Very importantly, we define when two events are disjoint. Following those definitions, in terms of set theory, we listed and discussed the Kolmogorov three axiom with which the theory of modern probability is built. While discussing the third axiom, which is the one notoriously more difficult to remember and understand, we briefly mention how the modern theory of probability is related to measure theory. Finally, we started to prove some important propositions which follows Kolmogorov axioms.